Okay, so this is our part 2 now. Our part 1, we saw how we were trying to determine the concentration in grams per decimeter cubed and mole per decimeter cubed. So I believe something was gotten from our first video regarding molarity and concentration. Now, some other questions that you're going to find involving concentration and molarity are these. The first question here, or question 2 rather, suggests to say, determine the new concentration of sodium hydroxide. Okay, determine the new concentration of sodium hydroxide, and then we're seeing to say that 1.25 molar if it was diluted from 10 centimeters cubed to 15 centimeters cubed. So determine the new concentration of sodium hydroxide with molarity 1.25 molar if it was diluted from 10 centimeters cubed to 15 centimeters cubed here. Now, one thing that we need to know anytime we're handling these questions is this. We had established initially that concentration, or molarity in this case, is number of moles over volume. Okay, concentration is number of moles over volume. That's what we had initially established. But better, let me try to use this. M is equal to N over V. I want us to see the relationship that is there between molarity and volume. Now, when you're establishing the relationship that is there between molarity and volume, you need to ensure that your number of moles is constant. Anytime you're deriving your relationship between molarity and volume, you need to ensure that your number of moles is constant. Why? Because your number of moles here is just a derivative of mass. Your number of moles is just a derivative of mass. And how do we say when we're talking about mass? We say that the mass of a substance can neither be created nor destroyed, but can only be converted from one form into another. So mass is constant. It cannot be created nor destroyed. And because the number of moles is a derivative of mass, the number of moles as well should be considered to be constant. Because even if we look at the formula for the number of moles is just going to be given by N is equal to mass over your molar mass. It's always there. N is equal to mass over the molar mass. So you can be able to tell that your number of moles is just a derivative of the mass. If the mass is going to be considered to be constant here, then your number of moles as well should be taken to be constant anytime you are talking about these things. So what's the relationship that is there between the molarity and the volume, provided that the number of moles is constant? The relationship is that the molarity is inversely proportional to the volume. That's always how the rule is. Molarity is always inversely proportional to the volume. They are never directly proportional. When I say that the molarity is inversely proportional to the volume, I mean when your molarity values are going up, your volume values are going to be dropping down. Conversely, if your molarity values are dropping down, your volume values are going to be increasing. This is what I mean when I say that they are inversely proportional. If they were directly proportional, then if my molarity values go up, then my volume values are also going to go up. If my molarity values go down, then my volume values are also going to go down. This is what we would have said if they were directly proportional, but just looking at the way they are positioned even, you can be able to see that your molarity and your volume are inversely proportional. If you increase your molarity values, your volume values are going to decrease, and if you increase, or rather if you decrease your molarity values, your volume values are going to increase. So they don't increase at the same time, and they don't increase at the same time. When one increases, the other one must reduce. This is what we mean when we say that they are inversely proportional. So it's because of this reason that we can even make the number of moles the subject of the formula. When we make the number of moles the subject of the formula here, what we're just going to have is N is equal to mv. And remember, your N here, your number of moles, is a constant. So when the number of moles is constant, your molarity and your volume are inversely proportional. So with this expression, having seen that the number of moles is constant, we can further, let me just say, modify our equation that has been given. Because the number of moles is constant, we can modify this equation to be M1 V1 is equal to M2 V2. Because the number of moles is constant, you can easily modify that equation of yours, this relationship of yours, to M1 V1 is equal to M2 V2, where M1 is your initial molarity, V1 is your initial volume, M2 is your final molarity, and V2 is your final volume. When you are using this formula, the M1 V1 is equal to M2 V2, you don't necessarily need to convert your volume values to decimeters cubed. If your volume values have been expressed in centimeters cubed, just go directly like that. You will only have to make your conversions if you are using this formula, like concentration is equal to number of moles over volume, or concentration is equal to mass over volume. It is only in these two formulas that you should strictly convert your volume values to decimeters cubed. But if you are using your dilution formula, the M1 V1 is equal to M2 V2, you don't necessarily need to convert your volume values to decimeters cubed. If they're in centimeters cubed, then it's fine, just directly like that. Okay, it's fine. So let us try to explain what we have just introduced here. The M1 V1 is equal to M2 V2. Let's see how we can now apply this to our question 2 under molarity and concentration. So in this problem, they're saying determine the new concentration of sodium hydroxide, 1.25 molar, if it was diluted from 10 centimeter cubed to 15 centimeter cubed. Our initial molarity or our initial concentration in this problem is going to be 1.25. They're saying if it was diluted from 10 centimeters cubed to 15 centimeters cubed. We're having two volume values here, which means that your 10 centimeters cubed is your initial volume, okay? And your 15 centimeters cubed is going to be your final volume. So your initial molarity or your initial concentration is going to be 1.25 molar. Your initial volume is going to be 10 centimeters cubed. They're saying determine the new concentration. That new concentration that you're going to be determining is going to be your final molarity. And your V2, your final volume, is definitely going to be 15 centimeters cubed. It's always essential that someone makes this analysis before just diving in and answering these questions. So M1 V1 is equal to M2 V2. There is nothing hard here. Our M1 is just our molarity one or concentration one, which is 1.25 molar. That's the 1.25 that you're seeing me right here. Your volume 1 is going to be 10 centimeters cubed. That's the same 10 that you have seen me right here. There is no need for you to start converting it into decimeters cubed. No, unless, like I said, you are using these two formulas like concentration is equal to number of moles over volume, or concentration is equal to mass over volume. If you are using these two formulas, it's a must. Your volume values needs to be converted in decimeters cubed. But in this one, I mean, just go direct and straightforward. No need for you to make your conversions. Your molarity number 2, that's what you're looking for. That's your new concentration that you're trying to find here. Okay, that's your new concentration that you're trying to find there. So let us just leave it as M2. Your volume 2, your final volume, that's the 15 centimeters cubed that you're seeing me right here. So M2, if you play around with this, that is, if you try to make your M2 the subject of the formula, this is going to be M2 is equal to 1.25 times 10, and then this is just going to be divided by 15. And 1.25 times 10 divided by 15, the answer is just going to be 0.83, like that, 0.83. So this is how we can use our dilution formula in trying to determine the new concentration. They can play around with this. Maybe both values of concentration can be given, the initial one and the final one, and then perhaps you might be asked maybe to determine the final volume. Such kind of questions can be brought, but again, it's always about knowing the formula. Once you take a hold of these formulas, everything is going to be easy for you. So M1V1 is equal to M2V2 is our dilution formula. Don't forget as well that concentration is equal to mass over volume. Again, concentration is equal to moles over volume. And not forgetting this basic formula, the number of moles is always equal to the mass over the molar mass. So I hope this helps.